So now we proceed to question 2.2. So question 2.2 reads as follows. Draw a labeled free body diagram of the 20 kg block. So they want us to draw the free body diagram of the 20 kg block. What is a free body diagram? So a free body diagram is a diagram that shows all the forces that are acting on this object. So it is a diagram that shows all the forces that are acting on this object, or all the forces that are felt by this object, or that are experienced by this object. So first of all, the most common one is force of gravity. Gravity is acting on me as I'm standing here, and it's acting on you as you are watching there. Second of all is the normal force. If an object is placed on a surface, there will always be a normal force acting on it, and it will always be perpendicular to the surface. So the most obvious is gravity because it acts in all of them. So normal force acts on objects that are placed on the surface, because if I'm hanging, the gravity will act on me, but there will be no normal force on me because I will not be standing or placed on any surface. So normal force is the force of the surface on the object, and it's always perpendicular to the surface. So let's draw the free body diagram. What are the forces that are acting here? So you will represent a free body diagram with a dot like this. So the first force that we talked is gravity. This is the force of gravity, Fg. The second force, because it is sitting on the surface here, the surface is exerting a force on this, which is vertical, which is perpendicular to our horizontal surface. So we have Fn, which is the normal force. This is the normal force. Then, what is another one? Another one is the applied force. Because it is applied at an angle, when you are drawing it, you should also draw it at an angle. That means you should preserve the same nature as this one, because the normal force is applied vertically upwards, and we represent it like that. Gravity is acting vertically downwards, it is like that. So even that one should also maintain the shape of 40 degrees to the horizontal. So here is our applied force. Force applied. These are vectors, so there should be arrow on top of them. So this is the applied force. What is the next one? The next one is the tension force. This is the tension force, this is the rope that is caused by the rope. This is the force that is caused by that rope, which is pulled by these guys, which is mass P and Q. And then the last one is the frictional force of 5 newtons that we were told. So because the object is moving to the right, that's what they said in the statement. They said it's moving to the right, which is this one is moving downwards. That means the frictional force is opposing the motion, which is it is on this side. So we have the frictional force here. Frictional force. So this is a free body diagram of this 20 kg block. So these are all the forces that are acting on this block. So this is where I will stop for question 2.2, because they wanted you to show all the forces that are acting on the 20 kg block. So these are your forces. So this is the most accurate free body diagram or representing all the forces that are here. However, as much as it is accurate and is correct, it is not very helpful when you want to do calculations that are relating to this. You will show this shortly Because when you're doing calculations, you want all the forces, your forces, to be either horizontal with your parallel with your surface, or perpendicular to your surface. So this one is not parallel, it's not perpendicular. It is at an angle. So it's not very useful when you want to do calculations. So what I will do now, I will try, let's go to question 2.3. That's why I'm going to try to sort this out, so that it can make things easier for you all the time and be able to perform calculations. So